Hello, welcome to Physics Basket. The topic that we are going to cover is Class 9 topic 11, and the topic is the problems on motion. So let's get started. Let's get started with the first problem. The problem says a truck of mass capital M is moving under the influence of a force F is loaded suddenly with a mass small m. Okay, and we need to find the ratio of the new acceleration with respect to the previous acceleration. So going back to the basics, since it is under the influence of force F, we know F is ma, right? So the acceleration in this case will be acceleration A will be equal to F by m, right? So this is the current situation, and what we do is we add an additional mass m, small m. So this one we are going to add, right? So we add this additional mass m here. So basically what becomes the total mass of the system will be capital M plus this small m, right? So the final mass becomes additional mass m getting added to the system, and then we already know the force remains the same. So obviously there will be some impact on the acceleration, because again going back to the basic formula, F is ma. In this case, capital F is capital M plus small m into a. Nothing but the new acceleration will be F by the total mass, or F by m plus m. So this is our new acceleration. So to find the ratio, it will be a1 by a, nothing but F by m plus m divided by F by m, and we get capital M divided by m plus m. So this is the solution. So for more on the correlation between the force, motion, and the momentum equations, we have already discussed that in the previous videos. You might refer chapter 1b for that. So coming back to the problems, the second one says that a car starts from with an initial velocity of 5 meter per second from a point A, and it crosses the final destination point B, which is 200 meters away from it, and with a velocity of 15 meter per second, which is the final velocity. So find the time taken to cross the destination B. So what is given we have in this case is we have the initial velocity, we can say u as per the convention, and u is 5 meter per second and v is 15 meter per second, and we have the uh, total distance, which is 200 s. So basically we might need to use some formulae to derive the total time taken here. So we know that v equal to u plus at. But we don't know here, we don't have t also, we don't have the acceleration also. So it would be better to find the acceleration first. So we can use this formula v square equal to u square plus 2as, wherein we can find the acceleration a. So in that case, the final velocity, the correlation between the initial and final velocity, we can use the formula v square equal to u square plus 2as, or a equal to v square minus u square by 2s. And with that, we can find the acceleration first, and then we can comfortably use, so we get the acceleration as 5 meter per second square, and we can comfortably use v equal to u plus at. So since a is also known, and then we know the initial and final velocities also, so t equal to v minus u by final velocity minus initial velocity by time, by acceleration, right? So in this case, t equal to v minus u by a, which is 15 minus 5 by 0.5, so we get 20 seconds. So 20 seconds is the time that the car would take to reach the final destination, 200 meters per second, which it crosses with a velocity of 15 meters per second. Of course, in this case, we have used two different formulas to derive and find out the final time that it takes. But there is an easier way. So we have already discussed the distance time graph, velocity time graph. So we can comfortably use velocity time graph in this case. And since we know the initial and final velocity, and we also know the total displacement. So basically the displacement, the correlation between the displacement and velocity time graph is the total area. If we recollect, the total area under the velocity time graph gives us the displacement. So if we quickly draw a diagram in the velocity time graph wherein velocity is in the y direction and the time is in the x direction, so that is the convention as always. And so initial velocity 5 we have drawn here, and the final velocity is what, 15, that we also know. So we have drawn a straight line right away, and this is the total time taken. We don't know, we are not aware of this, but then the total area, this area till here, till this is the total area, and this area is nothing but the displacement that has happened during this course of time, right? So we already know the displacement is 200. So quickly we can find out this area. So this is a trapezoid actually, and the time, this is the time, this part is the time. So the trapezoid, in this particular trapezoid, what is the formula? How do we find out the area of the trapezoid? Will be half into AD into BC plus BC, sorry, and into the base DC. So DC is unknown part because DC is the time here in this case. So let the total time be T, small t. So in this case, AD is what, 5, we already know, U, and BC is the final velocity V, so which is again 15. So we again just replace the values, and also we know S is equal to 200. So we say half into 5 plus 15 into T unknown is equal to 200, which is again the total displacement. So we get comfortably T equal to 200. So in this case, no use of multiple formulas, and straight away we draw as fast as we can draw the diagram, and we can quickly correlate the overall area of the trapezoid with the total displacement, and then we get the time by displacing the values. So let us start with the third problem, which says that a car starts with from rest and accelerates to a velocity of 90 meters per second in 2 minutes, and then it travels with a constant velocity. So it continues to travel with that attained velocity of 90 meters per second for next 10 minutes. So travels with a constant velocity means it has attained that particular velocity and it is traveling with the same velocity for 10 minutes, and then finally deaccelerates. So from 90 meters per second, in which it had traveled in the second phase of 10 minutes, it deaccelerates to rest in 1 minute. So it says what is the displacement. So we can find by conventional way. First thing is it starts from rest, which means that initial velocity in the first phase is 0 and final velocity in the first phase is 90 meters per second, and the total time in the first phase is an acceleration. Why I'm calling it as first phase? Because there are 3 phases in this case. First is acceleration phase, second is the constant velocity phase, and third is the deacceleration phase, wherein it is coming from initial attained velocity to a final velocity of 0 or rest, right? So this is what it is. So first initial phase we have u equal to 0, v equal to 90, and t equal to 2 minutes, which is nothing but 120 seconds. So taking that into consideration, we can find the displacement in the first phase. So let us first find the acceleration. So acceleration is v minus u by t, as we know the previous formula. So v equal to u plus at. So acceleration v minus u by t. So we get, replacing the values, of course we have taken into consideration that time need to be converted into seconds. So we got 0.75 meter per second square. So S1 in this case, S1 is ud plus half at square. T is already known, u is 0 because it starts from rest, so it is half at square. Replacing the values, we get the displacement during the first phase, which comes to be 5400 meters. Need to be taken care that every time we convert time, if it is in minutes, we need to be making sure that it is in seconds. So with that, we get the displacement in the first phase, and then in the second phase, we know that it is moving with a constant velocity, and it is going for 10 minutes. So what is the velocity in the second phase? Of course 90 meter per second, and time is 10. So for a uniform velocity, the formula will be velocity into time. So as simple as that. So v into t, and convert that t into seconds, and we get finally 54. So this is a conversion, and this is 54,000 meters. Now in the third phase, it is very similar to what is in the first phase, but the thing is, it is going through the deceleration phase, which means that the initial velocity is 90 and the final velocity is 0. So we need to find the acceleration in the third phase first. So we can say v equal to u plus at, or a equal to v minus u by t. 90 minus 0 minus 90, v is 0, right? So 0 minus 90 by t, so we get minus 1.5 meter per second. Why minus? Because acceleration is negative, or nothing but it's a deceleration in this particular case. So again, using the same formula, is equal to ud plus half a d square, we can get the value of the displacement. Of course, we need to take into consideration the negative value. So we get 5400 minus 2700, and we get 2700 meters. So with that, if we sum up all these three values, because the displacement during phase 1, phase 2, and phase 3, we get the final ask, which is nothing but the total displacement during the whole journey of the car. So we get the value, and which is equal to 62.1 kilometer. So this is one way, of course, when we have used the formulas and all. But of course, we know from the previous concepts that we can also use the velocity time graph. So let us try to do the alternate method also and see if we can save some time here. So let us draw it quickly. This is not distance. This will be velocity, right? So this is velocity time graph. So now if you want to do that, it is the starting point, right? So the starting point is here, starting point is 0, and because the velocity at time equal to 0 is also the initial velocity is 0, and then it attains a velocity of 90. So let us draw the diagram. So at this point, this is nothing but 120 seconds, right? So t equal to 2 minutes. So 120 second, we have already attained 90 meter per second. So 120, 90 is this coordinates, and then again it travels with 90 meter per second for 10 minutes. So let's go on the x-axis for 600 seconds. So we draw 600 seconds and 90 meters constant velocity. So it continues to be 600. Now it deaccelerates to from initial velocity to 0 in 1 minute. So with that, nothing but this part is 60, right? So this part is 60. So this part is 170 or 200. The middle part is 600, and the last part is 60. So we know all the coordinates now, all the values now, and with that, again we know that the total area, what it does, it says it is the total displacement during the whole course of time. So, and it is composed of three different areas, right? So it is, one of them as triangle. So if we draw all the vertex, so this is A, B, and this part is a triangle, and this middle part is basically a rectangle, and the third one is again a triangle. So we can quickly, this green one is triangle. So if we quickly draw, get the calculate the areas of the two triangles and the rectangle, we will get the value. So triangle area is half into perpendicular to base. So we will say this part is 90, of course, and this is 120. So half into 90 into 120. Middle one is directly we can multiply the sides. So it is 600 into 90, or 90 into 600. So we got this value, and then the third one is half into 90 into 60, this third part. So it is like the quicker we draw the diagram, we quickly go through the coordinates and then find out the values using the triangle and the rectangle formulas, area of the triangle and rectangle. So we get the same answer, 62.1 kilometer. So with this, we come to the end of this session, and the upcoming chapter that we are going to discuss will be the Class 9 Foundation topic 12, and wherein we again discuss the motions problem again, and that will be the part 2. So till then, have a good time and stay connected, stay subscribed and share to your friends for further updates. Thank you.